Good morning, good evening, ma'am. Myself Naveen. I am from CSMB section. Today's my topic is support vector machines SMV for classifications. Let us discuss about support vector machines SM for classification. The introduction to support vector machines. Let's discuss about support vector machines are supervised learning models used for classification and regression tasks. They excel in high dimensional space and are effective in cases where the number of dimensions exceeds the number of samples. SVMs are particularly useful for classification problems with clear margins of separation between classes. What are SMMs? Let's see the diagram introduction to SVM diagram, class 1 and class 2. The next slide is core concepts of SVM. SVMs work by finding the hyperplane that best separate different classes in the future space. The optimal hyperplane is determined by maximizing the margin between the closest point of the classes known as support vectors. Support vectors are critical to the model as they directly influence the position of the hyperplane. To see the diagram, the graph of support vectors, decision boundaries in x1 and x2. The types of SVMs. There are two main types of SVMs, linear SVMs and non-linear SVMs. Linear SVMs are used the data in linearly separable, while non-linear SVMs apply kernel functions for complex data distributions. Common kernel functions include polynomial, radial basis, function, RBF, and sigmoid, which transform the input space for better classification. The margins of a diagram. The next slide goes to the SVM algorithm. The SVM algorithm involves solving a convex optimization problem to find the optimal hyperplane. It minimizes a cost function subject to constraints that ensure correct classification of training data. The, this optimization leads to the identification of support vectors and the formulation of the decision boundary. The mainly advantages of SVM are effective in high dimension spaces and can handle large data sets efficiently. They are robust against overfitting, especially in dimensional setting, due to their margin maximizing property. SVMs are versatility and can be adapted to various types of classification problem throws the choice of kernel functions. The limitation of SVM. SVM can be less effective on very large data sets due to their combinational complexity and memory usage. They may struggle with noisy data or overlapping classes, which can lead to misclassifications. The choice of kernel and tuning of hyperparameters require careful consideration and can influence model performance significantly. The next slide goes to hyperparameter tuning. Important hyperparameters in SVM include the penalty parameter and the kernel parameter. The penalty parameter C controls the trade-off between maximizing the margin and minimizing classification error. Effective tuning of hyperparameter is essential for improving the model's performance and generalizations. The application of SVM. SVMs are widely used in various fields, including image recognition, text classification, and bioinformatics. In image recognition, SVMs can efficiently classify images based on pixel data and features. They are also applied in sentiment analysis and spam detection. Showcase their versatility in handling diverse data types. To see the applications of SVMs, there are 8 types of face detection, test and hype test quantification, classification of images, biformalities, protein fold and remote homology, handwriting recovery algorithm. The SVMs in practice. Implementing SVMs can be done using popular machine learning libraries such as scikit-learn and TensorFlow. Data pre-processing including normalization and feature selection is crucial for optimal SVM performance. Visualization of decision boundaries can help in understanding model behavior and evaluating performance. To see the diagram, most popular machine learning libraries 2013 to 2019. The last slide is conclusion. Support vector machines are a powerful tool for classification tasks, offering flexibility and robustness. Understanding the underlying concepts, advantages, and limitations is key to utilizing SVM efficiently. As machine learning continues to evolve, SVMs remain a prevalent choice for various classification problems. Okay, thank you.